welcome. Let me switch my slides here really quick. Great. So how's it going? Woo! Excited to be here. My name is Brian Holt. I'm very happy to be talking to this very full audience. I feel like it's one of those car commercials where you see like how many people are like in their individual cars, and if they all got in one bus, it would take like one bus, right? If everyone just sat like in the front row, we'd be totally full. So yeah, my name is Brian. I work at Microsoft, as it's pronounced. I am a program manager. I work on this little product called Visual Studio Code. Anyone ever heard of that? No? Totally new? It's kind of underground. You probably haven't heard of it. And then I am the program manager for Node.js all up on Azure. So that's a lot of fun. How many of you here are Node developers today at your day job? Just raise your hands. OK. How many of you do other sorts of JavaScript-y things like front end and? OK. How many of you are in the wrong room? And I always have to ask at a Microsoft conference, how many of you write PowerShell? I'm just always blown away by how many people write PowerShell. I had never even heard of PowerShell until I started Microsoft. So true story. Cool. So I'm just a recent convert to being a program manager. Before that, I spent a decade as a Node developer at LinkedIn, at Netflix, at Reddit, yeah, some other pretty fun places. And then I was a cloud advocate for a while before I transferred to working on the Visual Studio Code and JavaScript on Azure team. So if you have any complaints about Node.js on Azure, it's probably my fault. So probably just let me know. Cool. So here's kind of our agenda of what we're going to go over today. It's probably pretty hard to read, but there's 8 sections. So at least you get that information. So does Node.js scale? This is kind of the first thing that people tend to ask me, like, we're investigating Node, but we're worried about this newfangled V8 shoved in our servers, and does it work, and can it serve requests? Well, there's a very complicated answer that I have for you. Yeah, it definitely scales. That's it. I have no more to qualify for you. No, I'm just kidding. Yeah, it definitely does scale, right? So when I was working at Netflix, I was on the non-member team, which meant like if you ever go to like Netflix.com and you're not logged in, I wrote a lot of those pages. Which, as you can imagine, Netflix is a quite large company. That site gets quite a bit of traffic. And every single one of those requests goes through Node, 100%. It has to go through Node to get into that kind of broader microservice, infamous microservice architecture that Netflix has. When I was working at Reddit, we had the first iteration of Reddit chat. Have you ever used like the chat rooms inside of Reddit? No? OK, cool. So there's a chat feature inside of Reddit where you can like get into like a subreddit and chat with other people. Definitely not suggesting you do that because someone's going to find something terrible because it is Reddit. But you can try it if you want. So for all of that Reddit traffic, we were handling all of the Reddit connections initially with 3 Node servers for all of Reddit. Compare that to the, I think, over 100 Python servers we had serving the rest of the traffic. So all that to say, Node scales. It scales very well. There are some kind of things you have to consider given kind of the asynchronous event loop kind of nature of Node.js, which we'll talk about in some of these slides. But it definitely scales. I would consider it a mature technology, a boring technology choice. So it's good. It's good for your organization if you have JavaScript developers. So companies, this is just a very, very incomplete list of companies that are using Node.js at scale. Obviously, Microsoft, we use Node quite a bit. Netflix, Reddit, Walmart. Walmart serves all of like their Black Friday traffic using Node.js servers. Which, as you can imagine, it's Black Friday, it's Walmart. It's literally the definition of the thundering herd problem. There's PayPal, which is one of the biggest financial deployments of Node.js. Starbucks uses it quite extensively. Samsung, NASA, they do rockets and stuff. Might have heard of them too. And then Capital One as well, quite big users of Node.js. So Node does scale. So let's get into scaling Node then. So writing scalable Node.js. So the first thing I want to implore you to do is to first design for horizontal scalability. One of the things that people kind of make some mistakes early on with is that they don't first design with the idea that I'm going to have multiple servers. And this kind of goes across any sort of language, not just Node.js, but I've seen it in particular with companies using Node.js. So the best way to mitigate this kind of like, how do I do this, is always deploy 2 servers, right? Never deploy just 1 server, because if you deploy 2 servers, no matter what, they kind of have to be stateless, right? Because both servers have to be able to serve traffic. So if you have stateful workflows, which is fine, this sometimes happens where you have like, multiple requests have to go to the same server. We have a thing called durable functions on Azure, which I would highly suggest you test out. There are other things you can do. You can do like sticky sessions and working that through the load balancer if you have to. I wouldn't suggest it. I would avoid it if you can. And what's even better is if you can just avoid the whole problem altogether and just refactor all of your code to be stateless, right? That's generally going to be the best for you. And I've run into very few problems where it can't be refactored into something stateless. So yeah, for new services, always deploy more than 1 server. This will definitely force you into horizontal patterns. By the way, we have a couple mics up here, and since this is a little bit more intimate group, there's not so many of you, feel free to stand up and line up at the microphones if you have any questions. Cool. So horizontal scalability, that will definitely help you. Write modular monoliths. Now, I recognize that I came from Netflix, and I'm supposed to tell you everything must be a microservice, right? It's kind of like you get like a tattoo when you walk in the first day, microservices, right? Mine's kind of rubbing off a little bit. Microservices are amazing, but microservices solve organizational challenges, right? And if you don't have organizational challenges, then why are you taking this solution that solves organizational challenges, right? This is kind of the definition of premature optimization. Premature optimization kills companies. Or in this case, I probably put this better here, is the enemy of shipping good software. And so if you're building all these microservices for no reason other than Netflix told you to write microservices, you're going to create problems that you wouldn't already have, and it's not really solving anything for you. So in this particular case, it's kind of helpful to start with a monolith, which is kind of like, I know going against the pattern here, but monoliths in general tend to be simpler to write, right? Because all you have to do is clone 1 repo, get that 1 repo stood up, and all of a sudden your entire stack just works, right? So just be aware of that. So yeah, microservices is a solution to like a human problem, right? So the reason why microservices are very helpful at a company like Netflix is entirely decomposed into these kind of small teams, and each one of these teams manages 1 to maybe 5 at most microservices, right? So they're all only working on these smaller microservices, and they don't have to worry about what other teams do. So it's, what's the mantra they always repeat? It's loosely coupled and highly aligned, loosely coupled. Yep, that's it. Sorry, it took me a second. But it's kind of the idea that we kind of agree on these like contracts on how to interact with each other, and then we just kind of like go our separate ways and work on our individual problems, and we don't have to coordinate very closely, right? It's kind of the ideas of what microservices are going to solve for you. So if you don't want to do that, if you only have 10 developers working on 1 project, just make it 1 project, right? One person doesn't need their own microservice. I don't know, I mean, it sounds kind of fun, but it also sounds terrible. So monoliths are easy to write, easier to maintain. So that last thing there, and when I say modular monoliths, a lot of times these ideas still can be decomposed in kind of these ideas of services, and rather than just separating them out into different types of servers, you can just kind of make them into different like little modules that you import, right? Then eventually when your company grows big enough and you want to separate it, you just separate these things that were modules inside of your service into various different services. And if you kind of lean into that Node.js asynchronous by default sort of thing, it becomes pretty easy to separate into various different services. embrace event computing, event-based computing. So obviously Node is event-based, right? That's how callbacks work. That's how basically everything works with the event loop underneath the hood. So it makes sense to kind of lean into this paradigm because it affords you a lot of really cool opportunities. So going back to the modular monolith, if everything's based on this kind of like a centralized event-based computing system, it becomes, again, easy to separate things out. And a good example of that would be, let's say I have an e-commerce website, right? And every time someone buys something, I'll fire an event on the event. We'll call it the event grid because that's the name of the Azure service that will do that for you. Lucky that. And then you can have multiple subscribers to all these different events, right? So say someone purchases something on the e-commerce website, right? You can have accounting listening for events, and they can pull off events and say, okay, well, this is going into our ledger. You can have the warehouse listening for events, and they get pick lists of things to send to people. And you can have it be sent to inventory, and they can know to reorder things. But the beautiful part about this is they're all listening to events on this same kind of centralized event grid, and they don't have to know about that. Like the inventory team doesn't have to know what the accounting team is doing with those same events, right? So they get to be kind of decoupled in how they attack these various different problems. Now let's say our e-commerce website spreads, and now we have brick and mortar stores, right? Same thing, they can just publish events onto the event grid, the same event grid that we've been using, and now we just have multiple different publishers of the same sorts of events, right? If everyone's speaking the same event-based language, then everyone can understand each other. So this is, I think, a highly successful way of building large applications, especially in large enterprises. It's really good for like legacy migrations as well, because instead of having like your legacy application talk to your new greenfield application and kind of muddying the waters there, instead, what you can do is you can have them both just talk over the event grid, and eventually once all those events are being taken care of, you can just shut down those legacy applications, right? When I was hired at Netflix, God, like 4 or 5 years ago, my first big project was to try and shut down this like old legacy system. It is still running to this day. There are still parts of your traffic going through legacy Java systems at Netflix because there's just pieces of it that they can't rewrite because it's got too intertangled with the new system. So Azure Event Grid is a wonderful way to do this. There's many other services you can do it with, but I highly recommend Azure Event Grid. It's serverless, which means you're paying per event. It's very reasonable in that respect. It pairs well with like Azure Functions, Logic Apps, and we'll talk about serverless here in a second, so we'll get into that. But I'm a big fan of that service. And then it allows for better observability of your system, right? So you can just take a look at all the events that are going through your system, and you can kind of get this, the state, the health. You can gather metrics, those sorts of things. So, big fan of event-based computing as well. Embrace queuing. This is something I talk to a lot of Azure customers, and it's something that they frequently run into are things like port exhaustion, like trying to make too many requests at once, or overloading their databases, in particular with something like Cosmos DB, which you're billed based on how many requests per second you're making. If you start just making 20,000 requests a second all at once, you're going to get charged for that, and I would not recommend that. I mean, it's fine, it pays my paycheck, but you're not going to be happy about it. Instead, you can put all these kind of writes into a queue, and then you can pull things off the queue and kind of write them at your leisure. As long as those are not like time-sensitive sorts of things, that works perfectly, and then you can kind of have a better bill as well as have systems that don't get overwhelmed. So, and it's frequently writes to databases. I see that as like the first kind of place to use queuing. So Azure Storage Queues, really good way of doing that. Very inexpensive way of doing that, as well as Azure Service Bus, which is can get a bit more expensive, but has some more robust features to it. Happy to talk more about that after the presentation if anyone wants to. So by queuing your reads and writes, well, specifically your writes, you kind of get control of the fire hose going into your database, and that's going to be very helpful to you. So you can kind of let more things in, or pause things. Like let's say you have a huge spike of traffic, and you want to be able to lower the load on your databases. You can slow down those writes to make sure that all the reads are going out correctly. Particularly if it's like low priority stuff that needs to eventually make it into the database but doesn't have to be there right now. Perfect for that kind of stuff. And you just sidestep like a myriad of other types of problems if you just start with queuing. Like port exhaustion and thundering herd, right? If you can control that, like, you're not going to have 10,000 writes to the database because everything's going through the queuing system. And so I say it's a good way to kind of start with this, but also be aware that like adding queues does add like additional like steps into your process, which makes it hard to conceptualize in your brain. Additional surface areas for bugs. So again, premature optimization does kill companies and kills good software. So usually it's a good idea to have a problem before you solve a problem. That's kind of my mantra when it comes to these sorts of things. But you know your software better than I do. I'm just some jerk that works at Microsoft, so what do I know? So if the system's reads and writes to a database are going to scale at least linearly or exponentially, that's a good candidate. Like you should start thinking about how can I queue these kind of reads and writes. Cool. So let's talk about observability. Do you know where your servers are? Man, no laughs at my slides. I worked so hard on this. Fine, it wasn't even that good of a joke. Okay. So observability is all about knowing the uncomfortable truth about your applications. And like as an app developer, I really value this. And I think the ops team tends to value it because they like being able to point the finger at the right person. And I like to know that it's my fault before the ops team does. So a lot of times we like to bury our head in the sand because if we don't know about a problem, then we don't have to like worry about it. But usually it's better to have more foreknowledge of what's happening to your application so you can fix it during business hours instead of when you're on call. So it just helps you be proactive about brittle points in your architecture. So these are questions that, like you as an app developer, I think personally you should know. How many servers are you running? How long is system startup? What's the average CPU usage? What's the memory pressure? Like these are kind of things that like they're just kind of like table stakes, I think, for an app developer with their application. This should not be the exclusive domain of your operations team. You should work hand in hand with them on this kind of stuff. I'll also throw out a shout out to App Insights, Azure App Insights. Very helpful. And now with Node.js, as of fairly recently, we can do this automatically for you. We can do the instrumentation for App Insights for Node.js servers without you including anything. We'll automatically inject the App Insights key, and we can also instrument the App Insights SDK without you even requiring the SDK if you turn it on, right? So that's pretty cool as well. In addition to that, you can fire off custom events and all that sort of stuff, which will make it into the Azure Monitor dashboards, and you can learn more about your application. Do you know how to see the logs in your servers? Hopefully the answer to that question is yes. Hopefully some of you are feeling a little guilty and we'll go figure it out, right? That's kind of the point of this presentation. So log analytics, another part of Azure Monitor, makes that really easy to have consolidated logging. Like I remember when I worked at Reddit, we did not have consolidated logging. So if we had problems with our servers, I had to go SSH into each one of them and check the logs. And I'm probably not the only person here that's done that before. So it's much better if they're all in one place. And then if a server fails, how soon do you know? Do you know the answer to that question? So let's say you have a server that just, I don't know, crashes and has an uncaught exception. How long before you personally are notified of that happening? I bet you a lot of you don't know the answer to that question of how long that takes. I certainly wouldn't have when I worked at Reddit. So this is where something like chaos engineering can come in handy. Something I would highly suggest you all look into. There are some like limited offerings from Azure that will help you do some chaos testing, but like a more full feature thing like Chaos Monkey, again from Netflix, will help. Or you can use a company like Gremlin, who also does this kind of thing as a service. So then you can like purposely make parts of your application crash, so you can see what parts of your systems are brittle, right? Where your single points of failure are. And they'll like peg the CPU, they'll take all the memory, they'll inject high latency. all the fun things that you never want to happen. All right. Enterprise serverless. So I think serverless, I wish had been around a lot longer than it has. I think serverless would have helped me a lot when I was doing kind of these product engineering sorts of things. So the first thing, whenever I talk about serverless, I'm just going to point out, I damn well know there are servers, right? You don't have to tell me that there aren't servers. I know. So there's always some person in the back just like itching, just like to get the mic and say, where are the servers? Or, there are servers. I know, there are servers. That's fine. You don't have to tell me that. One of my colleagues said, you have to think less about the servers. That's why it's serverless, right? It's cheesy, but that's the term we're stuck with, so deal with it. So I like serverless because it helps me quickly finish common tasks, things that are not necessarily like part of my core application. Like a good example of that, like let's say someone uploads an image to your server and you want to generate thumbnails, right? You don't want to do that like on your main process of your server. You don't want to tie it up with all sorts of like calling out to like a C module, which is doing image processing and making people wait for that and raising the CPU on your app service for that kind of stuff, right? It'd be way better if that was just kind of like happening, being processed in the background. And you could spin up like another, I don't know, Python server or something like that to do stuff like that. Or you could let someone like Azure functions handle that kind of stuff for you. So that's what I really like about serverless, is it allows you to do these kind of quick and dirty tasks and kind of let the cloud provider handle all the infrastructure around it. You just kind of write the business logic for it. So we'll actually do a demo of that here in just a second. And you can spin up cost-effective APIs with serverless as well. And a good example is I do some teaching for an online learning platform on the side, and I run all my own APIs for that. And last month, I think that API had 3 million hits of like kind of doing like some caching and stuff like that. And I think it cost me like 60 cents to run last month, right? It can be incredibly cheap to run as well. And what's nice about it is like you don't have to worry about scaling. You don't have to worry about handling HTTP requests. You don't have to worry about what the runtime is or what the server-side framework is and updating all of that or what hardware it's on. With serverless, you just like write the function that you need and you say, hey Azure, do things with this. I'm done with it, right? Basically, is kind of the MO for that. I like to own less, personally, right? The more that I can offload of like all that sort of stuff and put onto the cloud provider, obviously it costs a little bit more, right? I could write this cheaper myself, but I could also just like run that computer in my basement and with my own hardware that I designed and do it for, you know, $40, but I don't want to, right? There's a human cost associated with that, and serverless really helps with that. And then you can also take care of like really common tasks with kind of like an if this then that sort of mentality with Azure Logic Apps, and I'm actually going to give you a demo of that. A lot of people don't like these visual designers. I didn't. Like it just felt wrong. It's like I know how to code. Just let me code it. But I was actually able to do some really cool things very quickly with Azure Logic Apps. So I'm actually going to show you the demo that I was just talking about, which is generating thumbnails using Azure Logic Apps as well as Microsoft Cognitive Services. All right. Whoops. Make that a little bit bigger. All right. Some of these are going to have to refresh for a second. So I have here an Azure storage account. Storage, you can just put anything in here. This is blob storage, which is kind of a weird name to me, but blob storage just means like it's an amorphous amount of data that we don't really care what it is. You can just put whatever you want there. So this can be things like documents. It can be things like images. So what I want is I have 2 containers here in my blob storage. I have pics and thumbnails. Oh, you can actually see this because I was making sure everything worked. We'll just delete that. But the idea is whenever I upload an image here into pics, so you can maybe imagine this was like a user uploading their avatar, right? I want to put that in blob storage, and then I want to make thumbnails out of it. Yeah. So I could go write a bunch of code. I could put this directly in the API endpoint that would do it, but like I said, this would be unnecessarily pegging the CPU of my processor, of my servers. So I just want to make it so anything gets uploaded to Pix, then it goes to thumbnails. Now I could do this with Azure Functions as well. I could pull in something like PNG, Quant, or Crush, or whatever those image processing libraries are called. But it'd be really nice if I didn't even have to write the code for that, because I'm sure most of us have written that kind of code at least once. It's not fun code. It feels like kind of like a solved problem, right? So I'm going to show you how to do that with Azure Logic Apps. So we're going to click here on Logic Apps. We'll create a new one. And we'll call this Thumbnailify. Use existing, BR Holt. Put this in East. US number 2, and we'll not do that. So then we'll click create. Usually these are pretty fast to create. There we go. Go to resource. Make this a little bit smaller so I can see it. All right, so the idea with Logic Apps is you have some sort of trigger, right? This is event-based. So something happens, and then you want to do something. So what's our trigger here? Our trigger is someone uploaded something to blob storage. But you can see here we have many, many triggers. I think certainly over 100 at this point. I'm not exactly sure how many, but if you have like a situation, we probably have a trigger for it, and if we don't, we can probably make one for it. So you can see here, like, you can do things when someone tweets something. You can do it when someone calls an endpoint. You can do it just like every 30 minutes, right? All these kind of things are possible. So here, I'm just going to start with a blank Logic app. Oh, and then there's these recipes as well. Actually, something I use Logic apps mostly for is sending emails, right? If this happens, send this person an email. It's just the easiest way to do that, and I hate writing email code. I don't know if you've written email code before, but it is the worst. OK, Azure Blob Storage. So this is what we're going to do our trigger on, so I'm going to click that. And when someone adds or modifies something in some blob storage container, so I have to select the container, and I'm going to select Pix. And we're going to check every 10 seconds because I am not a patient person. OK, so that is the trigger. That's it. So now every time this happens, every 10 seconds, it's going to check to see if there's a new blob in there. If there is, it's going to run this. If there's not, it will not run this. So I'm going to add a new step. And what I'm going to do is I'm going to do a data operation. And I'm going to parse the JSON coming in from the blob storage, right? Because it's going to pass me the new blob that was updated. And the data operations are things like pull this out, get this in. Parse JSON specifically saying, like, I'm expecting this shape of data, and so pull these sorts of things out. And so at that point, the Logic app will kind of give you like almost like IntelliSense type completions, like, oh, OK, this comes from here and goes here. So the easiest way to tell it what kind of schema is in here is by using a sample payload. And I just happen to have one right here. Oh, I need one from Microsoft, Ignite, demo, and cat blob pb copy. OK. Where'd you go? There we go. OK, so this is a sample JSON. You can see here it's just like a normal JSON amount. So I say done here. It then generates like, OK, there's an idea here. It's a string. There's a name here. It's a string. It kind of gives me like a schema for this. You can write this yourself by hand. I'm just far too lazy to do that. And I'm going to tell it it's going to come from the list of files, which it knows comes from blob storage up here. OK? So now I can add a new step. And the next thing I want to do is I want to go back to the Azure Blob Storage, and I want to get it out of Blob Storage. Because it doesn't actually give me the file contents. It just gives me the file metadata. So here I'm going to say get available, oh, no, not that one, get blob content right there using path. So the blob path is going to come from path, right? Path came from the parse JSON operation. Okay? That's it. And for a content type, you say yes. So if it's a .jpg, assume that it's not lying to you. Okay, next thing here is I'm going to say use the computer vision API. And I'm going to say generate thumbnail. And we want ours to be like, let's say 400 by 400. And the image source is going to come from image content. And the image content is going to come from the file content, which we got from the previous step. Smart cropping is like, if I have like a person's face in the top left, and then the other part of it's just like sky or something like that, which I don't know how you got that picture, but congratulations. It'll crop it around the person's face. It'll find the most interesting part of the picture using AI. Okay? And then last new step here is we're going to go back to the Azure Blob Storage, and we're going to say create blob. Yep, create blob. Folder path, we want to put it in the thumbnails. We want the blob name to be the same as the display name. And we want the blob content to be the generated thumbnail image. Okay, that's it. Save that. Now, I could have written a bunch of Node to do this. Wouldn't have been that hard, but it would have taken me a lot longer than this, right? Now, hopefully to prove my point, I can say pics. We'll say upload. We'll select a file. And I have one here in Holt Pictures. Let's do this one. That's my dog. Okay, upload. Okay, uploaded a 3 megabyte file. If you go back to the Logic App Designer here. So if we hit refresh, it'll take a second to start that run. There it goes, running. And you can see here it's gotten through this step. This one took a second. Right now it's in the machine vision. That took 4 seconds, so overall about 6 seconds. So now if we go back over here, I uploaded this image here, but now if I go back over to thumbnails, you can see here I have a picture here, and it is a square picture of my dog, which has been sized down, right? So pretty compelling, right? Again, I'm not one for visual code designers or anything like that, but this is really easy, right? And like we did this in, what, like 6 minutes together? So pretty cool. All right. Nice thing about that as well, like I've heard of companies training like their accountants how to use Logic Apps. So if they need like some sort of like CSV report generated from some sort of data, they can go into Logic Apps and generate those reports themselves and not have to ask engineering at all, which is pretty cool. And if you have any like custom blocks of code that you need inside of Logic Apps, you just write an Azure function that the Logic App calls, does some processing, and returns that. So you can put kind of blocks of code in there as well. Cool. Deploy continuously with confidence. Bring DevOps deeper into your organization. So when I say DevOps, I don't mean Azure DevOps, which is a greatly named product. I mean that you have developers doing operations. And I think that's appropriate given a lot of organizations that developers should be more involved with their own code and how it gets out to production. So continuous deployment and integration is all about getting the latest code to production with confidence, right? So as soon as I push code, how soon can I get it out there so that users are getting the best code as soon as possible, and I can be confident that I'm not breaking anything in the process. And I think part of that is failing fast, loud, with context, and to the correct people with the correct issue. Like the worst error in the world is seg fault. Like I still wake up with like nightmare sweats from college of things segfaulting, because it just gives you no context. It's like, it broke, right? And I hate that. So that's why I think CI and CD can be really helpful. It can tell you immediately, this broke here on this line for this reason. This is probably how you're going to fix it, right? And the shorter amount of time it takes me from writing that to getting that in front of the developer, I think is helpful. So Azure DevOps is a really great way of doing that, but I also want to sell you on GitHub Actions as well. And GitHub Actions, obviously, are kind of the new thing. I think they're now out of private preview and into public preview, so I think anyone can use Actions. And it works very similar to Azure DevOps in many ways, specifically Azure Pipelines, and allows you to quickly deploy with confidence. So I do have a demo of this. Let's actually just go in here. Well, no, we can do it really quick. I only have about 9 minutes, so I want to be able to show you the last demo as well. All right. Actions example. So all I can do is I come in here to Actions. So this is a Gatsby application. It has a bunch of like pre-made actions for you. So you can do like a Node one, a Rust one. You can have it close like old stale issues for you. There's a bunch of stuff you can do with it. I'm just going to do a basic workflow. And there is a marketplace over here, so I can come in here and say I want a Gatsby action. Now I'm going to save you me hand coding all this, and I'm just going to copy and paste the correct YAML. But needless to say, this is not very hard to set up. So it checks it out. It runs tests. And let's just cut that out for now. And then here, it's going to use the Gatsby GitHub pages, which is this one right here, the publish one, which is going to build the Gatsby project and then immediately publish it to GitHub pages. So I'm just going to say start commit new file. It makes this YAML file. And I can actually go over here to the actions. And if I refresh fast enough, eventually it's going to start building my project for me. Yep. So it's actually going to kick off a build immediately. It's going to go through. It's going to check it out, install Node, run npm install, run npm run build, and then publish that to the GH pages branch, which is automatically going to be a GitHub page. So now publishing to GitHub pages is incredibly easy. And this will also work for Azure as well. I was just showing you a really simple one that hopefully is useful to you today that you can go home and publish your own projects. So, there you go. So I'll spare you watching yet another npm install. You do plenty of that during your day job. But suffice to say, I promise you this works. All right. Don't solve solved problems. And this is kind of getting back to us telling you that I like to own as little as possible. So if you have something like, you could either go and run your own MongoDB cluster, or you could use something like Cosmos DB. I'm going to say maybe consider using Cosmos DB, because that means you have to own less of the management, right? If you spin up Cosmos DB, we just give you back a connection string, and you just go out and start writing your application. If you have to worry about primaries, secondaries, sharding, election classes, observers, and worrying about like cross-region partitioning and things like that, it gets hairy quickly. And then not only do you have to set it up, you have to maintain it over time. It's not fun. I don't think it's fun. And if you think it's fun, then you probably should make a lot of money. So I'm just going to implore you to think about using, when you're thinking about pricing these services out, please include the human cost of it. Obviously, running your own Mongo cluster is going to be cheaper than Cosmos. Actually, and I don't even always know that's true either, but usually, right? Usually cloud managed services have a little bit of a premium on them. But think about, I have to have 3 more operations people to manage that versus if I just let Azure do it for me, then it's a lot cheaper, right? All right. I have a big soft spot in my heart for developer experience. So that's what I worked on when I worked at LinkedIn. It's part of what I worked on when I worked at Netflix. is how do I make other developers more productive? And this gets more and more important when you get into enterprise scenarios. A big part of this is shortening the feedback loop, right? And I alluded to this earlier, but when a developer writes a bug, how long does it take them before they notice the bug? Like, how long is that cycle? Ideally, it's instant, right? This is why Visual Studio Code is so awesome, because you just get the red squiggly underneath it immediately. This is perfect. This is exactly what you want, because the developer still has everything in their brain that they have been thinking about, and they don't have to regain context, right? Whereas, like, if you have like a really long continuous integration process and it lets them know the next day is like, by the way, your build yesterday broke, they have to go back and regain all that context. That can be upward of hours to regain all that context, right? So it's always good to frame things in terms of that. However, anything that you introduce into your system, like linting, type checking, tests, any sort of like code quality checking, PRs, that's intentional inefficiency in a process, right? A developer has an idea of how they want to solve a problem, and they express that, and then you're telling them it's not what you wanted, right? That's intentional inefficiency, hopefully at the cost of having less bugs, or hopefully at the value of having less bugs. But make sure you're intentional about that for every linting rule that you add, it should be useful. It should be intentional. And in general, err on the side of letting developers express their ideas as purely as possible. So if you're telling me that I need to use semicolons or not use semicolons, I don't care. Or like this kind of white space versus that other kind of white space, it just doesn't matter, right? Don't tell me things because it makes the code pretty, because I just don't care, right? I want to express my problem-solving ability, and I think that's the most important part about this. Let's see, got 3 minutes. You should test your code. That's basically what that said. And these slides will be posted as well. So from zero to productive, how many of you started a company and it took you like 3 weeks to even stand up like the environment? It's like most companies, right? So wouldn't it be nice if you just like got there and you just had a VM that was pre-set up and everything just worked? I would think so, right? So I'm going to show you a couple of these things from VS Code. All right, so let's hop into VS Code. Oh, that's a video of it. All right, so I'm in a repo here. It's probably pretty hard to read, but suffice to say, it's a bunch of different environments. So I'm going to hop into one of these environments, which is the Dart environment. I don't know anything about Dart. Like maybe if there's some Flutter fans in here, or I don't know, Angular.Dart fans. Do those exist? And I'm going to open a project that depends on Dart. But I don't know how to start it. I don't know how to set it up. I definitely don't have any Dart tooling on my computer. But you can see here, it immediately asks me when I open this project, hey, this has a dev container associated with it. Do you want to open this in a dev container? I'm going to say, OK, sure. So now it's actually spun up a Docker container with all the Dart stuff installed. I don't have to muddy up my host computer. And you can see here, I'm just started up inside of a container. So if I look at what's in, let's see, issue, you can see that I'm actually running inside a Debian. So I'm now going to go into the test project, and I'm going to say Dart, server.dart, and it's listening on localhost 8080. And I just have to go in here and forward that port from the container to the host. And it's going to say, oh, I think there's one listening on 8080. It can detect that for you. So I just click that, open in browser. And now I am running a Dart project on my computer, knowing nothing about it, just using containers and VS Code. Pretty compelling, right? Yeah. So this is instable today. Feel free to go play around with that. And I got 30 seconds to show you one more thing. Where is VS Code? Come back. So you might have seen a little announcement, VS Online. I just wanted to show you how cool this is. I can click on this. I have a remote dev box set up here. I just say connect to environment. It kicks up the VM. It's going to connect my VS Code directly to that cloud environment. This is something that my employer could have set up for me. When I travel, I typically don't travel with my 15-inch. I travel with like a little Surface Go, which is powered by a potato chip. And I just can connect to my dev box, do all my remote development on that, and then I can just shut it down, and like it can, do real development on a cloud environment using a really underpowered device. I mean, in theory, this could work from your phone. This could work from many different sorts of environments. And here you go. This is now connected to a remotely running environment. And I can do full-on debugging. Let's just go ahead and get this server started here. I'm going to say node index.js. And click here. And I'm going to open this, and you can see now this is actually tunneling through VS Code now, and it's available on localhost 3000, and I was able to just run this locally as if it was running on my computer, but it's actually running in a cloud environment. Who knows where? So VS Online, super exciting. Definitely go kick the tires on that. There's only going to be more cool stuff coming from the VS Code team on that. And with that, thank you. So I'll be around to answer questions for a little bit, so feel free to come chat.